How do you prove the Pythagorean theorem? There are more than 300 ways to prove the Pythagorean theorem. Here is one of them. You want to prove that for any right triangle, a squared plus b squared equals c squared. Let's start the proof by studying a square. All the sides in a square are of equal length, and all the angles are 90 degrees. The square can be divided into 4 identical right triangles and a square, like this. How this is done will be explained later in the video. You can prove the Pythagorean theorem by using the fact that the areas of these two figures are equal. Said in a different way, the area of the larger square on the left equals the sum of the areas of the 4 right triangles plus the area of the smaller square in the middle of them on the right. This equality can also be expressed as an equation. Area left equals area right. And it turns out that after a little algebra, this equation, when filled in with the expressions for the areas, can be turned into the Pythagorean theorem. A squared plus b squared equals c squared. Cool, don't you think? Now it's time to find out why. Let's start with this figure. First, you divide one of the edges into 2 parts like this. It doesn't matter where, and the 2 parts don't need to be equal. Name one line segment A and the other line segment B. Now, divide up the other 3 sides in the exact same way. Then, you draw line segments between the points on neighboring edges like this, creating a quadrilateral and 4 right triangles. The 4 triangles are identical, or congruent, because 2 pairs of corresponding sides and the corresponding angle between them are congruent. That means that the lengths of the hypotenuses of these triangles are also all the same. Let's name the lengths of the hypotenuses C. But what about the quadrilateral in the middle? It does look like a square, but can you be sure? It's time to find out. Let's add some colors to help see the different shapes better. The lengths of the sides of the inner quadrilateral are all equal to C, because they are the hypotenuses of the triangles, which are congruent. What remains is to show that all the angles are 90 degrees. If they are, then the quadrilateral is definitely a square. Recall that the angle sum of a triangle equals 180 degrees. In a right triangle, one of the angles is exactly 90 degrees. That means the sum of the 2 remaining angles must be 90 degrees, as 180 degrees minus 90 degrees equals 90 degrees. So, the sum of the angles with either 1 or 2 hash marks is therefore 90 degrees. Now, let's zoom in on just one of the edges of the outer square. Recall that 1 half rotation is 180 degrees. Since the angles labeled with 1 and 2 hash marks equal 90 degrees in total, the remaining angle you want to find, here named alpha, must be 180 degrees minus 90 degrees, which is 90 degrees. The same argument can be used for all 4 angles in the quadrilateral, meaning all 4 of those angles are right angles. And we already know all the sides are equal. The quadrilateral must therefore be a square. Now you have all the information you need to prove the Pythagorean theorem from the 2 figures. Recall the equation that you were introduced to earlier. Area left equals area right. Based on what you've learned about our figures here, you now know that the area of the blue figure is equal to the sum of the areas of the pink and purple figures. So area left equals area right then becomes area blue equals area purple plus area pink. The area of the blue square is the quantity a plus b squared, because the lengths of its sides are a plus b. The area of the purple square is c squared, because the lengths of its sides are all c. Finally, the area of one of the right triangles is AB over 2. Since there are 4 triangles, you multiply AB over 2 by 4 to get the area of all the pink triangles. That leaves you with the following equation and some fun algebra. The quantity a plus b squared equals c squared plus 4 times ab over 2. The left side of the equation is the square of a sum. Recall that the quantity a plus b squared is the same as the quantity a plus b times the quantity a plus b, which is a squared plus 2ab plus b squared. The right side of the equation is c squared plus 4 times ab over 2. You cancel 4 against 2, which leaves 2 in the numerator. So 4ab over 2 equals 2ab. Now you have the following equation. A squared plus 2ab plus b squared equals c squared plus 2ab. You can now subtract 2ab from both sides of the equation, and you are left with a squared plus b squared equals c squared, which is the Pythagorean theorem. How funny! You've used squares to prove a property about triangles. There are more than 300 ways to prove the Pythagorean theorem. You have just seen one of them.